In the name of God, hello everyone. I am Dr. Ahmad Fahmi, a faculty member at the university and the innovator of GEOtExcel project, Soil Mechanics and Foundation Engineering Excel Spreadsheets. I invite you to watch a new video from the GEOtExcel project. Thank you very much. Concept 1. Soil is composed of three phases. Introduce soil phases, then describe dry, saturated, and moist soil conditions. Explore 1. A specific volume of soil in natural state consists of solid particles and the void spaces between them. Next. In dry soil, there is no water in the void space. In saturated soil, the entire void space is filled with water. If water partially occupies the void space, the soil is categorized as moist. Concept 2. Introduce the volumes and weights of soil phases. Explore 2. VA. Volume of air in the voids. VW. Volume of water in the voids. VS. Volume of soil solids. WA. The weight of the air is negligible. WW. Weight of water. WS. Weight of soil solids. Total volume. Volume of voids is equal to VA plus VW. Total weight. Concept 3. Define and introduce the volumes and weights of soil phases, water content, moisture as a weight relationship. Explore 3. Water content. The water content, moisture, represents the proportion of water weight to solid weight. In this example, the calculation W is equal to 7.14%. Concept 4. Define the following volumetric relationships: void ratio, porosity. What is the relationship between them? Explore 4. Void ratio. The void ratio represents the proportion of void volume to solid volume. In this example, calculation. A is equal to 1. In other example, void volume is equal to 6 cubic centimeter. In this example, calculation A equals to 6 over 10. A equals to porosity. The porosity represents the proportion of void volume to total volume. In this example, calculation In this example, the values of these two factors, E and N, and the calculation changing the content of the water phase in soil has no effect on the change in porosity and void ratio. That was the answer to this question. Does changing the content of the water phase in soil have any effect on the changing in porosity and void ratio? Changing the water content has no effect on the change in porosity and void ratio. Concept 6. Define the saturation rate, degree of saturation as a volumetric relationship. Explore 6. Saturation rate. The saturation rate represents the proportion of water volume to void volume. In this example, calculation. Concept 7. Does changing the content of the water phase in soil have any effect on the change of saturation rate? Explore 7. Yes. Change in the content of the water phase in soil affects the saturation rate. Concept 8. Define the following volumetric relationships: air content and percentage air voids. Explore 8. Air content. The air content represents the proportion of air volume to void volume. Calculation. AC. Percentage air voids. The percentage air voids represents the proportion of air volume to total volume. Na equals to Concept 9. Does changing the content of the water phase have any effect on the change of air content and percentage air voids? Explore 9. Yes. Change in the content of the water phase in soil affects the air content. And similarly, change in the content of the water phase in soil affects the percentage air voids. Concept 10. Describe the unit weight of three phases of soil, air, water, and solid, separately. Explore 10. Water cube. The weight of 1 cubic centimeter water is equal to 1 grams. The weight of 1 cubic meter water is 1000 kilograms. The weight of 1 cubic meter water is 9.81 kilonewtons. Air cube. The weight for air cube is negligible. The weight of 1 cubic meter air is negligible. Solid cubes of soils. The weight of 1 cubic centimeter of the clay is 2.72 grams, for example. For different clay soils or sand soil. For example, clay and silty clay. For example, sand. Concept 11. Define the specific gravity relative density of soil solids. Explore 11. Water cube versus solid cube of soil. For two cubes with 1 cubic centimeter or 1 cubic meter, comma W, and comma S for solid weights. For different soils such as clay, sand, silt, and other soils. A specific gravity or relative density of soil solids. Gs is equal to gamma S over gamma W. equal to 2.73 over 1. Unit weight of soil solids, S, unit weight of water. Specific gravity. Concept 12. First describe the unit weight of soil, then compare it with the unit weights of its three phases, air, water, and solid. Explore 12. Unit weight of water, air. Unit weight of water. Unit weight of soil solids. Three-phase soil, unit weight. Specific gravity. For different units, S, total gamma, Concept 13. Define the following weight-volumetric relationships: dry unit weights of soil, moist unit weight of soil, or total unit weight of soil or unit weight of soil, and saturated unit weight of soil. Explore 13. Dry unit weight. Two important equations. Moisture unit weight, two equations, and saturated unit weight. Concept 14. Do the dry and saturated unit weights of soil represents the lower and upper limits for the unit weight of soil. Explore 14. Comma D for this example is equal to this is a lower limit, comma, and gamma saturation. Gamma saturation is upper limit. Changing the water content. Lower limit is constant. And upper limit is constant. But unit weight, moisture, or total unit weight is changing with the changing of water volume. The graphs for limits. Concept 15. Compare all the unit weight parameters related to soil and its phase with each other. Explore 50. For example, Explore 60. Examine the correlation between the weight-volume parameters listed below: water content, specific gravity, void ratio, and saturation rate. Explore 16. WGS is equal to SRE, the important equation.